Question number 5.270. A voltage applied to an X-ray tube is being increased by a factor n equals to 1.5 times. The short wave limit of X-ray continuous spectrum shift by a wavelength delta lambda is equals to 26 picometer. Find the initial voltage applied to this X-ray tube. Okay, so in this problem, suppose there is X-ray tube, okay, and some X-ray emission is taking place when we are applying some voltage across it. Okay, and suppose it emits a wavelength lambda. So energy of emitted rays would be hc over lambda, or sometimes in some book you would see it is written as 2hc over lambda. Okay, so there is very basic relation that this h cap is equals to h over 2 pi, where h is Planck's constant. So no need to get confused. You can use either of the relation. Okay, and that is equals to potential applied, energy due to applied potential, that is E into V. Right. So from here we can write the initial wavelength before change in voltage lambda 1, let me write, is EV over 2 pi h cap into C. Right. And when we increase the voltage by eta times, then let's assume this wavelength is lambda 2. So this is eta EV over 2 pi h cap into C. Right. So from there we can calculate delta lambda, that is lambda 1 minus lambda 2, or lambda 2 minus lambda 1. So delta lambda is lambda 2 minus lambda 1, which is equals to NEV upon 2 pi HC minus EV over 2 pi HC. Right? So from here we'll get N minus 1 into EV divided by 2 pi HC, okay, is equals to, I'm committing some mistake, I think, that lambda 1 is equals to O. This is, I think I wrote in reverse manner. 1 second. This is 2 pi hc upon lambda is equals to EV. So from here we can write lambda 1 is equals to 2 pi h cap c over EV. Right. Similarly, for second, we can write lambda 2 is equals to 2 pi hc over n into EV. Okay, so if we'll subtract them, then we'll get delta lambda is equals to 2 pi hc over EV is common, right? And this is 1 over n minus n, 1 over n minus 1, right? So from here we'll get delta lambda is equals to 2 pi hc over EV into 1 minus n over n, right? So from there we can write V is equals to 2 pi hc over delta lambda into 1 minus n over n. Okay. So now we can substitute numeric values here. Okay. So H is equals to 6.626 into 10 to power minus 34, and rest of the numeric values are known. C is equals to 2 pi upon 3 into 10 to power 8. So this h cap can be replaced by h over 2 pi. So from here we'll get 6.626 into 10 to power 34 into speed of light 3 into 10 to power 8 divided by lambda. Okay, and this delta lambda is equals to 26 picometer. 26 into 10 to power minus 12 into charge of an electron into 0.5 upon 1.5, right? So from here we'll get V equals to 15.9 kilovolt.